Assalamualaikum students. The first topic of A2 Chemistry 9701, which we'll essentially be looking at, is physical chemistry. And even in physical chemistry, as a subtopic of physical chemistry, we'll be looking at chemical energetics. The first definition which we need to learn in chemical energetics, and that is also mentioned in your syllabus, is lattice enthalpy. Now, let's understand this word by word. Enthalpy is also another word for energy. And what do you mean by lattices? Lattices simply refers to uniformly arranged rows and columns. This is what a lattice refers to. Have you ever seen many balls which are stacked together to form a sort of a cube? Well, that is a lattice as well. Lattice does not specifically apply to chemistry or chemical equations or chemical relations. No, lattice is a simple word. And what do you mean by lattice enthalpy? Lattice enthalpy or lattice energy simply means the energy which is released when gaseous ions react together to form 1 mole of ionic solid. Let's repeat this. Lattice energy refers to the energy which is released. So it's not the energy which is taken in, it's the energy released. As a result of which, we understand that bond formation is happening, which is exothermic. And this is why energy is released. This energy is released when gaseous ions. Now, there are two things here. They are ions, the species are ions, and they are also in the gaseous state. They react together and they form 1 mole of ionic solid. Let's say, for example, I have a sodium gaseous ion and a chloride gaseous ion. They react together to form 1 mole of sodium chloride in its solid standard state. Another example would be a potassium gaseous ion reacting with a bromide gaseous ion to form potassium bromide. Now, when an ionic bond forms, what does it actually mean? It means that electrostatic forces of attraction are developing. I repeat, when an ionic bond forms, it actually means that electrostatic forces of attraction are developing between oppositely charged ions. So let's say I have a sodium ion here and a chloride ion here. Between both these ions, some forces of attraction are developing. These are called electrostatic forces of attraction, or in this case, it's called an ionic bond. Now, it goes without saying that the stronger the ionic bond is, the greater the amount of energy released. Because bond forming is a process which releases energy. We know that from AS level that bond forming is exothermic, so energy is released. So the stronger a bond is formed, the greater the amount of energy is released. And the energy which is released is simply called lattice enthalpy. Well, one might think, what could be the factors affecting the strength of the ionic bond? Because stronger the ionic bond, greater the energy released, more negative the lattice enthalpy. But what makes an ionic bond stronger or weaker? There are two factors. The first is the charge on the ions. Let's take an example to understand this. I have Na plus Cl minus, and on the other hand, I have Mg2 plus and Cl minus. Cl minus and Cl minus are the same on both sides, so I can cancel them out. Now the competition is between a sodium ion and a magnesium ion. The thing is, a magnesium ion has a 2 plus charge. It is able to attract the same chloride ion, not the same chloride ion, but it is able to attract the chloride ion more strongly. Now, when you compare it to a sodium ion, because it has only a +1 charge, not a +2 charge, it is able to attract the chloride ion less strongly or weaker. So because it attracts it less strongly or at a weaker amount, as a result of which the ionic bond which is formed is weaker or has a lower strength. Obviously, when someone throws a ball at you at a faster speed, it comes to you at a faster speed as well, right? The stronger the sodium ion and the magnesium ion pull the chloride ion, the stronger the ionic bond itself is formed, right? So, because magnesium ion have a greater charge, they attract the chloride ions more strongly. as a result of which a stronger ionic bond is formed. And this is why greater amount of energy is released. This is the more dominant factor. Now, what do I mean by the more dominant factor? There is another factor as well, but in a question where it asks you comparing between two different ionic compounds and formula units, and it says which one of these two has a more negative lattice enthalpy. You will look at which one of these two has a more stronger ionic bond. And from that, you will look at which one of these two ionic compounds has a greater charge, not this. This is the more dominant factor. If the charge is same, for example, if I had K plus here and Cl minus, and then Na plus here and Cl minus. Now Cl minus gets cut. Na plus and K plus have the same charge. So now this factor is not relevant. Then I move on to this factor. And this is almost the same example given here. If I have Li plus and Cl minus and K plus and Cl minus, this gets cut. Both of the cations have the same charge. Now I look at the size of the ion. A lithium ion is above or in higher positions in the groups of the periodic table, but a potassium ion is lower down in the group. What does that mean? As we go down the group, the atomic size and the ionic size increases. This means potassium ion has a bigger size. A lithium ion has a smaller size. Now, what does that mean? Let's say I have a lithium ion here and I have a potassium ion here. Both of these have a plus one charge. The thing is, for a potassium ion, the plus one charge is spread over a larger area. Why? Because a potassium ion has a greater size. So because the charge is spread over a larger area, it is able to attract the chloride ions weakly. But now let's take a look at lithium chloride. The same charge is concentrated in a smaller area. It's not spread, it's instead concentrated. So because of that, it will be able to attract the chloride ion more strongly. Because it attracts it more strongly, the stronger ionic bond is formed. Because stronger ionic bond is formed, the greater amount of energy is released. Let's take a look at a past paper question. It says to state whether the lattice energy of sodium oxide would be more negative, meaning more exothermic, less exothermic, or the same as that of K2O. Give reasons for your answer. Firstly, step one for this should be to write down the ions making up the ionic compound. For example, Na2O. What is it made of? It's made of a sodium ion and an oxide ion. Let's just write that down. 2Na plus gas plus O2 minus gas gives sodium oxide, and potassium oxide is made up of a potassium ion and an oxide ion. We have now listed the ions. Step one is complete. Let's look at step two. Which one of these from sodium oxide or potassium oxide has a stronger ionic bond? Well, what factor should we look when we are looking for a stronger ionic bond or a weaker ionic bond? Two factors, because these are the only two factors which affect the ionic bond's strength. What is that? The charge on the ions and the ionic radius. So, in both cases, the oxide ion is the same, and now we are only left to choose between sodium ion and potassium ion. Again, both of them have the same charge. I always look at the charge first. You never look at the size first. Only if the charges are the same, then you move on to the size checking. So Na plus and K plus have the same charge. Now I move on to the size. A sodium ion has a smaller size. Their charge is concentrated over a smaller area. So will it be able to attract the oxide ion more strongly or more weakly? It will be more strongly. For a potassium ion, it will be able to attract it weakly, as a result of which the sodium oxide ionic compound will have a more negative lattice enthalpy or more exothermic lattice energy. That will be it.